Okay, a few questions on sets. Question 10, 2015. A researcher has found old census data about measles, chickenpox, and whooping cough among 12-year-old children. In a group of 100 children, 31 had none of the diseases, 2 had all 3 diseases, 2 had measles and chickenpox, but not whooping cough, 6 had whooping cough and chickenpox, 11 had at least 2 diseases, 18 had measles, 40 had chickenpox. Use this data to fill in the Venn diagram. Okay, and as I fill it in, I want to try and explain, I suppose, the more common mistakes that we all make when it comes to sets. Okay, the first one, 31 had none of the diseases. Okay, so therefore 31 exists out here. This is the universal set, which is everybody. Okay, so in U we must add up to 100. Okay, so 31 on the outside means they didn't have measles, they didn't have chickenpox, it's like a tongue twister, chickenpox, and they didn't have whooping cough. Okay, so that's the 31 that had none of the diseases. The area that shows that you had all 3 diseases is this area here. Okay, this is the area where the 3 circles overlap. Okay, so there is measles, there is chickenpox, and there is whooping cough. Okay, so this is the only area that I can color in that is part of all 3 circles. Okay, so that is the area that shows you have had all 3, which means the 2 goes in there. Okay, and you can see I tick off the lines as I'm doing it. Okay, next one, 2 had measles and chickenpox, but not whooping cough. Okay, but not whooping cough means, maybe not that one, means the circle is out of the picture. Okay, so cover that one with your hand because it says but not whooping cough. Okay, so then it's easier to see then that this is the area there that is measles and chickenpox. That's the only place that's part of the 2 circles. So that is also a 2. Okay, now the next one, 6 had whooping cough and chickenpox. Whooping cough and chickenpox. Okay, so I'm writing it in red because it's wrong, okay? But this is a very common mistake that's made, that you put the 6 in there, okay? 6 had whooping cough and chickenpox, okay? And let me explain why. So there is chickenpox and there is whooping cough, okay? So where do these 2 circles intersect? It's here. Do you see it's around those 2 areas? Okay, it didn't say but not measles. Okay, so it's both of them there. So the 2 of those areas have to add up to this 6 that's here. And you can see they don't at the moment because I put the full 6 in here. So I have them adding up to 8. Okay, so that's a very common mistake that's made. What goes in there is 4. So that both of these add up to 6. That is the area that is common between chickenpox and whooping cough. Okay, so look at the difference in the wording. This one said but not, this one didn't. Okay, so watch out for that mistake. That's very easy to make. Okay, 11 had at least 2 diseases. Okay, so at least 2 is this area. It is also this area because that's 3 diseases, and 3 diseases is at least 2. It's this area and it's this area. Okay, so they have to all add up to 11. So I have 4, 5, 6, 7, 8. So 3 is going to go in here. Okay, so you can see now I have 4 and 3 and 2. So 4, 5, 6, 7, 8. 9 people had 2 diseases and these 2 had 3 diseases. So that's 11 having at least 2 diseases. 18 had measles, so very easy, very common mistake. I should have written that one in red to stick the 18 in there. But again, that's not correct because this whole circle is measles. Okay, so that means the whole circle has to add up to 18, not measles only. That's how you describe that area out there. Okay, so I have 3, 4, 5, 6, 7. Take 7 away from the 18. So I have 11 out there having measles. 40 had chickenpox. So in the same way, this whole circle has to add up to 40. So I have 4, 5, 6, 7, 8. Take 8 away from 40 and I have 32. Okay, I have one area left. Okay, it's perfectly acceptable that there's nothing in it, but how do I check that? Well, I'm going to see, have I accounted for all 100 children? Okay, because hash u, maths language. Okay, so hash is the number of elements in. So the number of people, children in this stage, in the whole set U has to add up to 100. So I have 31 plus 32 plus 2 plus 2 plus 4 plus 3 plus 11. Let's see what that equals. So I'm just popping onto my calculator. 31 plus 32 plus 2, 4, 8 plus 11, 12, 13, 14. I make that to be 85. So 100 minus 85 is 15. So 15 goes in here. Okay. So the question then said, so that's your Venn diagram done. Okay, and there's quite a lot of marks for a Venn diagram, so it's a good thing to be able to do. And there's often a sets question on papers, so again, important that you know all the sets. Find the probability that a child chosen at random from the group has chickenpox. Okay, so probability, there's a formula for it. It's called the number of successes over, if I could spell, over total number of outcomes. Okay, so that's the formula for any probability. So our successes in this case is how many children has chickenpox. Okay, that's what we regard as a success. It meets whatever you're finding the probability of. So chickenpox was 40. The total number of outcomes is the total number that could ever happen. So it's 100. So you can put it as 2 over 5 if you want, or 40%. Whatever way you can do it. Any of these answers is perfectly acceptable. Okay, and that was that question.